Today we are looking at circles, area, and circumference. This is the second part of this lesson. So we're just going to go back first of all, and we're going to have a look at the two formulas which we learnt yesterday for this. So what was one of the formulas that we learnt yesterday with circles? What was the formula for area? Pop your hand up if you know. So pop your hand up if you know what the area of a circle is. Good, there we go. Some people have put it in there. Right, I'm going to write it on here anyway. You can see some people have put it in the notes. Yeah, so the area of a circle is equal to pi times by the radius squared. I am going to start by writing that just because it's important that we know what these formulas are. We also need the formula for circumference. What was the formula for circumference? You should have this in your notes from yesterday. Pop your hand up if you know. Well done. Yeah, that's it. It's going to be pi times by diameter. Or we could say that it's 2 times pi times by the radius. Some people say that one as well. So both of those are for the circumference. Brilliant. So we're going to be looking at a problem-solving question today to get us started. This came from the OCR paper. It was actually in 2012. So get this question down then. Get this question down. So Parvinder has a bicycle. I think this would example 8, is it? Parvinder has a bicycle and each wheel has a diameter of 65.5 centimeters. On one journey, each wheel is rotated 3,509 times. Calculate the distance Parvinder cycled. Give your answer in kilometers. So this is 4 marks, this. 4 marks there. Four marks this one is. So, if I want to find the distance travelled, do I need to find out the area of this shape, or do I need to find the circumference for when a wheel turns round? What happens when a wheel turns round? What happens when a wheel turns round? I might even be able to find a little thing of this. Let me see if I can find it. Let me see. No, there's nothing good there. Oh, there you go, this is a good one. That's what I want. Let's see if I can get this up. Here we go. So have a look at this. So here I've got a circle, and the circle rotates. And you'll see that as you start here like this, as this circle rotates, one full rotation there is the circumference of that circle. Okay, one full rotation here is the circumference of a circle. Okay, so let's just write that down first of all, just so we know in our notes. One full rotation of a wheel or of a circle is the circumference. Can't type today. One full rotation of a circle is the circumference. So the first thing I'm going to need to do then is to find out what the circumference of this is. So remember from yesterday, the first thing we always do is always write down what the diameter and the radius is. Now we don't need the radius in this one, but I'm going to write it down anyway, just as a good habit. So my diameter is equal to 65.5 centimeters. My radius would be half of that, which is equal to 32.75 centimeters. I don't need to know that, but I'll put it down there anyway. So in which case my circumference is equal to pi times by 65.5, like so. So let's get that down. Shift pi times by 65.5. Now I'm going to need quite a few decimal places on this, and the reason for that is because I need to convert this into kilometers. So this one here is equal to 205.7743.188 centimeters. Okay, so this here is the distance travelled on one rotation. Now it tells us that the wheel rotated 3,509 times. So when I'm doing this, to find out how many, the total distance for all of these is going to be 3,509 times by 205.7734,188. So let's write that down. So that times by 3,509. So this is equal to, in centimetres, 722,000, sorry. And 62.08 centimetres. So this is how many centimetres travels, but the question says, give your answer in kilometres. So I know that if I want to give it in kilometres, I need to first of all convert that into metres, and then I need to convert that from metres into kilometres. Now we have done this, haven't we? We've done the conversions. So if I want to convert from centimetres into metres, I need to divide by, well, how many centimetres in a metre? If you think about a metre rule, quite big, 100 centimetres there, which is going to be this many meters. And then how many, remember kilometre means 1,000 meters. So to find out how many kilometers, I need to divide by 1,000. So if we divide this by 1,000, it's going to be 7.22062. I'm not going to need all of that. So it's just going to be 7.2 kilometers. Everybody happy with that? Pop your hand up if you're happy with that. Brilliant. Keep your hand up for me just so I can see that everybody knows. See. Good, good, good. Just a few. Good. Good. Right, has everybody got that down in the books? I hope so. We'll do one more question, then we're going to do this Dr. Frost task. So 7.2, brilliant. There's our answer. Absolutely super. Last little question we'll do. and then we'll have a look at that Dr. Frost task. So this here, to get this one down, I think this is the last example we're going to do on area of circles. So this one here says, calculate the area of the shaded region. So I'm just going to zoom in a little bit here so you can see that. So, get that down, get that picture, get that diagram down. Now we're trying to find out the area of that shaded region. Now this one here is a little bit tricky. It's not that much trickier, but it is a little bit trickier. Now to find the area of the shaded region, we need to first of all, why is that doing that? Second time it's done that to me today. We need to first of all find out the area of this rectangle, and that's easy enough. But we don't want the area of the rectangle, we want the area of the shaded region. So to find the area of the shaded region, we're going to need to get rid of the area of that semicircle here. So the first thing we're going to do is to find out the area of the red rectangle, which is this one here. So let's write down area of the rectangle. And the area of the rectangle is obviously length times width, which in this case is going to be 8 times by 12. So let's work out what that is. 8 times by 12, which is equal to 96 centimeters squared, like so. Brilliant. Now then we need to take away the area of that semicircle. So the area of the semicircle is equal to, well, again, the same as always, we need to first of all write down what the diameter and the radius is. Now the diameter of this is equal to 8 centimeters. You can see that. Because here is the same as the top and bottom, is it? That there is 8 centimeters. Which means that my radius is equal to half of this, which is 4 centimeters. Now, because it's a semicircle, I need to do half the area of a circle. So it's going to be pi r squared divided by 2. So that's going to be pi times by 4 squared divided by 2. We'll put that in our calculators. Remember, the pi button is the one above the times 10 to the x. And we're going to have to press the fraction button first. So fraction, shift pi times by 4 squared, all divided by 2, is equal to 8 pi centimeters squared. But we're going to do this in decimals, so we'll do 25 point, well, the actual answer, let's write it all down so we've got it, 25.13274.123. We'll do it to one decimal place. We put that there, highlight the number which changes it. So the 3 means I stay the same. So actually the answer to this one here is 25.1 centimeters squared. Now remember that we don't want just the area of the semicircle. We don't want the area of the rectangle. The whole point of this is that we're trying to find the area of the shaded. Now to find the area of the shaded, I'm just going to shade it in again so you can see. This is the bit that we want. Okay? And to do that, we need the area of the rectangle. So the area of the shaded is equal to the area of the rectangle subtract the area of the semicircle. And the area of the rectangle is 96. Subtract the area of the semicircle, which is 25.1. Let's do that. 96 subtract 25.1 is equal to 70.9 centimetres squared. Brilliant. Okay, so that's all of the questions. So that's all of the modelling to do for circumference of an area of a circle and circumference of a circle. So if you're catching up later, I'm going to give you some questions to have a go at. If you're catching up later on YouTube, then pause now and have a go at these questions. So if you're catching up, have a go at those questions. There is another sheet here, so if you're catching up, pause and have a go at these questions. Some trickier ones towards the end there. And if you're catching up and you want the answers, here are the answers to all of those.